Welcome back to the channel, guys. Let's move on to the next problem, which says minimize the maximum difference between heights. Like the last problem, it is also marked as very important. So let's look what does the problem say. The problem says given an array ARR denoting the heights of n towers and a positive integer k, for each star you must perform exactly one of the following operations exactly once. Increase the height of the tower by k, decrease the height of the tower by k. Find out the minimum possible difference between the height of the shortest and tallest towers after you have modified each tower. You can find slight modification of the problem here. Note, it is compulsory to increase or decrease with the height by k for each tower. After the operation, the resultant array should not contain any negative integers. It would be easy to explain you with this example: 3, 9, 12, 16, 20. Let me clear the screen. Yeah, so examples here it says 3, 9, 12, 16, and 20. Look carefully at the example. Okay, the problem is slightly tough. Okay, it says, and the given k is given as to be 3. K is given to be 3. It says these are the heights of the towers. These represents heights of towers, and the answer here is maximum minus minimum. Like the maximum present in this array is 20 here, and the minimum present in the array is 3 here. This is our answer. Okay. Answer in the sense, like we have to report the maximum difference, the maximum difference, so the minimum difference between the maximum height that is 20 and the minimum height that is 3. All right. So, but we have to perform exactly k operations. The one operation means either adding k, either ARRI equals to ARRI plus k, or ARRI equals to minus k. All right. So if we see here 3, 9, 12, 16, and 20 possible no modifications after k is, it can be 0, or it can be 3 plus 3 6. It can be converted to 6 or 12. It can be converted to 9 or 15. It can be converted to 13 or 19. It can be converted to 17 or 23. These are the possible. Okay. So if I see here, what is the minimum difference? Like minimum difference, to find out the minimum difference, tallest minus smallest tower, right? That is our answer, right? So to minimize this expression, this one expression, I have to decrease the tallest as far as I can, and I have to increase smallest as far as I can. All right. So many of you will say it is not a big problem. You just for the tallest, just sort the array. The last element would be the tallest tower, and the first element would be the smallest tower. For answer, add k to the smallest, and add and subtract k from tallest. Yeah, that is why to decrease you will have to subtract, right? And for increase you will have to add. So we say that add k to the smallest and k to the and and subtract k from the tallest. In this way, the answer would be tallest minus k minus smallest plus k, which would give us the rise of tallest minus smallest minus 2k. But what if I say this will not give the correct answer always? For example, if you have a test case 3, what the test case given above was 3, 9, 12, 16, 20, 3, 9, 12, 16, 20. What if uh, 18 was present here? Just a minute, not 18. Mm, what can I say? Something like, sorry, this one, not this one, like the case we have example is 3, 5, 7, and k is 4 here. What would happen in this case? You would say that 7 minus 4 minus 3 plus 4, which gives rise to 7 minus 3 minus 8. It is 4 minus 8 minus 4 is the answer. But have you forgotten about 5? That 5 has to go either to 1 or to 9 or to 9. But what if it is, if 5 is going to 1, then the smallest would be 1, right? And in this case, smallest is 3. So our answer is wrong here. So what should we do? The problem arises, how should we proceed? For that, let me make it easy for you. 3, 9, 12, 16, 20. I say that let us take a definite answer. Answer 20 minus 3. Assuming I add 3, add and k was a 3 here. I add k to 20 and I add k to 3. In this way 17. I can achieve 17 at least. Matlab 17 is the maximum answer. We have to find an answer which is less than 17. We have to find an answer which is less than 17. So what how should we proceed for that? I say that now the smallest tower should be of height 3 plus k. That is ARR of 0 plus k. And the largest tower should be of height ARR of n minus 1 minus k. That is 20 minus k. I assume this. The smallest tower is of height 3 plus k, and the largest tower of height is of ARR n minus 1 k. After modification, right? I have to minimize the difference, so that you were correct above that you have to add to the smallest and decrease from the tallest. So that's what I have done here. Okay. I say run a loop. Run a loop and check at every step that what is the smallest and largest you can achieve. All right, that is what I want to say, that for loop is running. Update smallest, take a variable mini as minimum of smallest, which is this one, and ARR of I plus 1 minus 1. That is at the index 3, at ARR of I plus 1 minus k. Sorry for my mistake. At index 3, the smallest should be 6 minus k. It can be 3, right? Smallest can be 6. This one was 6. Smallest can be the minimum of 6 or 3. In this case, smallest is 3, alright. And maxi equals to maximum of largest and adding k to the ith index. Understand, it's a deep point here. The array given to us was 3, 6, 9, 12, 16, 20. We were able to achieve 20 minus 3, 17 at any cost. Okay, we want an answer less than 17. All right. Okay, we have k in our hand. I am saying run a loop from here and go up till this index. Okay, at each index, like we are here, find a minimum which is minimum of smallest and ARR of I plus 1 minus k. The problem we saw in this example 357k equals to 4 was that we were doing 3 plus 4 and 7 minus 4, and 5 did have two options, that 1 and 9. So it was surpassing 3 here and it was coming 9 here. So we have to see that 5 lies where. 5 lies where? What is the position of 5 in respect to the smallest and the largest? That is why I'm choosing ARR of I plus 1 minus k. Alright, and for maxi, check if it is largest than the largest we have described, larger than the largest you have described, or ARR I plus k. Okay, after that, you have done that. Now, the question also says the resultant array should not contain any negative integers. Obviously, we are given with the tower heights. Tower heights can never be negative. So, if our mini is less than 0, we will have to discard it, because obviously, while computing smallest, we did plus k. So, smallest is positive number. Smallest is a positive number. If smallest is a positive number and mini is negative, that means ARR I plus 1 minus k is a negative number. This implies ARR of I plus 1 minus k is a negative number. Alright. So we have to discard that, because if it is a negative number, then the transformation of minus k cannot happen on this index. On the I plus 1 index, it has only the option of plus k. The the option of plus k would be implemented in the next step when the I changes to I plus 1. Okay. So if mini is less than 0, continue. Move to the next step. Okay. Else, if mini is greater than equals to 0, update your answer. Answer equals to minimum, because you have to find the minimum height difference of the existing answer and the found out maxi minus mini, because maxi is a new largest and mini is a new smallest, so answer would be the minimum of these two. Okay, and after the loop, return answer. Let's code it down. I will try to make you understand the problem once again on the notes after the code. It would be easier. I said that it is not necessary that we are provided with a sorted array. So in the first step, sort the array. Sorting done. I said the definite answer is, like the answer we have in hand at all times, is ARR of n minus 1 minus of ARR 0. Okay. Now I say the smallest that could be present is ARR 0 plus k, after adding the k to the smallest tower, and the largest that could be present is ARR of n minus 1, that is the last element, minus k. Alright. I actually declared two variables here, is mini, comma maxi. And now run a loop. I will tell you from where to run a loop. Let's leave it. Uh, I say that update mini and maxi accordingly. What was our mini? Our mini was minimum of smallest and here are I plus 1 of minus k. Okay, and our maxi was max of largest and here are I of k. Now if error I plus 1 minus k is negative, that then our mini will be negative because the smallest term is always positive. Here is spelling mistake. Smallest term is also always positive because error 0 is positive, that is given in the constraints also. Error I is always greater than 1. Error 0 is positive and k is also positive, and 2 positive when added will become 2 positive only. So smallest is our positive number. And if minimum is negative, that means error I plus 1 minus k is negative. And if error I plus 1 minus k is negative, then we are checking for a negative height of a tower. That is not possible because it is given here that it is compulsory to increase or decrease the height by k for each tower. After the operation, the resultant array should not contain any negative integers. So negative integers should not be present. So this operation is not possible. So we just skip this step. Else, if the step is not skipped, that means minimum is greater than or equal to 0. We update our answer accordingly. We find the minimum of the existing answer and the maximum minus mini we obtain in the above steps. At last, after the loop is run, we just return the answer. Now I see that we are finding for I plus 1. Now if I will go up till the n minus 1th index and then do the operation, then I plus 1 will convert it to n, and but there is no index n in the array. It will be out of bound error. So what I will do, I will just move to the n minus 2th index. Int I equals to 0, I less than n minus 1, I plus plus. I think I'm clear. Let's try and compile and run it. It is running fine for compile and run. That means there is no error present in the code. Let's try to submit it. Thankfully, it has been submitted. Let me make you understand it once again at the final attempt. We had 3, 6, 9, 12, 16, and 20. I think 3 was not here. Yeah, 3 was not here. Oh, sorry, 6 was not here. Sorry. Yeah, 3, 9, 12, 16, and 20. Okay. I said that the definite answer is 20 minus 3. How come? Suppose we added k to 20 and we added k to the 3. We have got 17 in our hands. All right. I say the smallest you could make out of all these is 3 plus k after adding k. Okay, because to minimize the difference, you have to decrease the taller one and you have to increase the smaller one. All right. Smallest is 3 plus k. You have increased the smaller one, and largest is 20 minus k because you have to decrease the taller one. All right. Both the steps done. I say now move a loop, start a loop for I equal to 0 where we move up to n minus 2th index. And each time find a mini that is minimum of smallest, comma, ARR of I plus 1 minus k and maximum of largest and ARR of I plus 1 of ARR of I plus k. Now if mini is less than 0, continue because the height cannot be negative. Else answer equals to minimum of existing answer, comma max c minus min. And at last, after the loop terminates, return the answer. Please drop a question in the comment box if you have left any. Thank you. Please watch. Thank you. Thanks for watching my video. Please like and subscribe and comment on the video.